Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, we'll continue the topic of two-factor ANOVA, looking at how to calculate main effects and marginal means and kind of talking about what those things are. So now that we're working with two factors or two predictors in our ANOVA, we have to take into account the individual effects of each predictor on the outcome. And we call these main effects. So a main effect is going to examine the mean differences on one predictor while completely ignoring the other predictor. In the context of our video game example, this means that we would look at the gender main effect, would be the mean difference between boys and girls, completely disregarding video game condition or collapsing over video game condition. The video game main effect would examine the mean differences among the experimental conditions, collapsing across gender groups or entirely ignoring gender. The main effects compare what we call marginal means that reflect the overall effect of each of the predictors in isolation, again, ignoring the other predictor. So the gender marginal means would be computed by combining all of the males and all of the females into two groups, averaging over condition. So ignoring video game condition, it would just be the aggression scores for males and the aggression scores for females, totally ignoring video game condition. The video game condition marginal means would be computed by combining all of the conditions into three groups. So it would be the means for each of the three groups, totally ignoring gender. Here are the gender marginal means. So we can see here that we've actually broken this table out into the means for each condition. So we have the condition, the cell means, for each cell. So that's the crossed conditions. So we have the control, nonviolent, and violent means for males, and then the control, nonviolent, and violent means for females. So the marginal means are essentially, the reason we call them marginal means is they're the means that we can see on the margins of these tables. So the gender marginal means are highlighted here with kind of distributions next to them to show what these distributions look like. So the male marginal mean on aggression is 4.7, and the female marginal mean on aggression is 3.3. I'd also like to point out here that in the bottom row in the column all the way to the right, the gray box that says GM equals 4, that's referring to the grand mean, and that is the mean on the aggression, right? The mean score for aggression that's completely ignoring both gender and video game. So if we were just to take the mean of the single aggression variable, that would be the grand mean, and that would be 4. The video game marginal means are, again, highlighted here, and we can see the different distributions above the table of the means to kind of show that what they might look like if they came from separate populations. So the completely ignoring gender, the control mean aggression is 2.5, and the nonviolent aggression, the nonviolent group aggression is 3.5, and the violent group aggression is 6.0. And also the number in the parentheses below each of the marginal means is the deviation between the grand mean and the marginal mean. So again, the grand mean being that mean that's in the gray box in the lower right of this table. So we can get this information from SPSS output if we ask for the estimated marginal means. And again, when we talk about the marginal means, we're completely ignoring the other factor, and we're just breaking it out by each factor at a time. So when we see in SPSS these tables, we actually are not going to see the cell means at all. It's just going to print out the marginal means by factor. So the first one is for video game, and we can see those means, again, represented here. And the second one is for gender, and we can see, again, those gender means in this SPSS output. So there's some additional notation that we use for marginal means, and it kind of helps us to create a decomposition of effects if we want to refer to them in an equation. So the first subscript, you'll see that each of these cell means has a subscript. Okay, so there are the 6 cell means, and each in each subscript, the first subscript indexes the row, and then the second subscript indexes the column. So, for example, if we look at the mean for the control group males, we can see that it's Y bar sub 1, 1, and that would mean that this is the first row and the first column. For the female and the control condition mean, that's 3, that's right below that, we can see that it's Y sub 2, 1, which indicates that it's in the second row and the first column, and so on. And then for the marginal means, we have this notation where we use a dot, and a dot denotes that it's the marginal mean. So the dot is either going to go in the row that is in the row location if it's a column marginal mean, or it's going to go in the column location if it's a row marginal mean. So for example, if we look at the male marginal mean, it's Y sub 1 dot. And that's telling us that this is the marginal mean for the first row, no column, ignoring column. Same for female, Y sub 2 dot is indicating that it's the marginal mean for the second row. If we look at the control marginal mean, it's Y sub dot 1, indicating to us that that is the column 1 marginal mean, ignoring row, and so on. So now that we understand the concept of the marginal means, let's look at how they relate to the calculation of the actual main effects, or the effects that we would calculate for each factor, ignoring the other factor. So this is a plot of the grand mean. Again, that grand mean was equal to 4. We just saw that in a previous table. And this is showing the plot over the, for example, the plot has aggression, the outcome on the y-axis, and then we have the video game condition on the x-axis, control, nonviolent, and violent. So now let's take a look at how we would calculate this male group effect. So this would be the group effect for male, and it's simply going to be the difference between the grand mean and that male marginal mean. And we've already looked at these numbers, and we've actually already looked at these deviations as well. I showed those to you a couple of slides back, but we can see here that this male group effect is plus 0.7, positive 0.7, because it's the difference between the male group mean of 4.7 and the grand mean of 4. So this orange line now is representing the plot for the male group effect. Note that it is completely straight across the control, nonviolent, and violent conditions because we are ignoring that factor. We're totally ignoring the condition factor when we calculate this male group effect. Same thing for the female group effect. So we know that the female marginal mean was 3.3, and so the difference between 3.3 and 4 is negative 0.7, and so the female group effect falls slightly below. It's less than the grand mean. This is indicating to us the female group effect. Again, that's completely ignoring the video game condition. So now let's take a look at how we might calculate the control group effect. So we just calculated the female and the male group effect, and so now those lines are represented here, okay? But now we can look at the control group effect, again ignoring gender. And how we're ignoring gender is that we've got these individual lines for male and female, but we're essentially shifting those lines from where they stand when we're ignoring video game condition, shifting them in whatever direction the group effect goes. So for example, here to calculate the group effect, we have the difference between the marginal mean for the control group and the grand mean is negative 1.5. So we're going to take both of those lines for male and female that we're completely ignoring the video game condition, and we're shifting them down each by 1.5. So same thing to do for the nonviolent group effect. The nonviolent group effect is negative 0.5, and we would take both of these points and shift them down negative 0.5. Then for the violent group effect, do the same thing. A violent group effect is positive 2, and so we're shifting those points up from where they fell to up 2 points. And so this gives us kind of this now these two lines indicate to us what these main effects look like kind of across the conditions, but ignoring the other condition. So adding the group effects to the grand mean gives us the predicted group means. Okay, so this is kind of showing you how that decomposition works. But essentially what this is saying is that each score is going to be equal to the grand mean plus some influence of predictor 1 plus some influence of predictor 2 plus some error. Okay, and by adding those group effects, those calculations of the predictor effect, the main effects, to the grand mean will give us the predicted group means. So the predicted group means represent the systematic part of each score that's attributable to the predictor variables. So what that's essentially saying is that these are the predicted means that incorporate, the predicted means are incorporating the effects of each predictor on the outcome. And again, here are the main, so this is what the main effects model would look like. So I've just kind of showed you how these lines get shifted around from using the grand mean and incorporating the group effects, right? So we took the grand mean and then we calculated the group effect and shifted these points around according to how each predictor sort of how each group mean deviated from the grand mean, or alternately thinking about it more of a regression framework type of thought, but how each predictor is influencing the outcome. And that would result in this model. So it's the grand mean plus these deviations from the grand mean representing the group effects. This concludes the second lecture on two-factor ANOVA, and in the next lecture, we will get into discussing the types of error and the score decomposition in the two-factor ANOVA framework.